we are now going to see fault related terms and information which will be useful in the cross section balancing studies. We need to understand two definitions of detachment in structural geology. In geoscience, there are few instances where the same word has two different meanings. For example, the word clay can have a mineralogic definition and also a sedimentological definition. In structural geology itself, the term detachment can be found to have two different meanings. One of the meanings is that detachments are low angle normal faults. A normal fault is a kind of a fault where the hanging wall block goes down with respect to the foot wall block, and when the dip of the normal fault is low, then we call this normal fault as a detachment. What is the second definition? Detachment or décollement is a plane that separates highly deformed rocks at the top from less deformed or undeformed rocks at the bottom. Take an example of a piece of wood and consider over that I have kept a cake, and this wood is kept on a horizontal surface and this wood is prevented to move. This wood is fixed with the horizontal surface. Now, if I am pushing both the wood and the cake by pistons, only cake will move and the wood will not move. In that case, the surface of the wood acts as a detachment or a décollement. In the geological case, wood can represent hard rock and difficult to deform, and the cake as the soft rock. Let us take ahead the example of wood and cake. I have consulted a carpenter and I have created this kind of a piece of wood and I have kept it on a horizontal surface, and other side, this side is a vertical wall. And now here I have put either cake or any soft material or say clay material. So, this is a piece of wood and this is a piece of clay. I have also taken another piece of wood, but of different geometry. And here also I have filled up by soft clay. What is the difference in the wooden material between case A and case B? In case A, this wood has sharp edges. This is one sharp edge and here also it has a sharp edge. What about case B? Here from this horizontal surface to this inclined surface of the wood, there is a smooth surface and here also it is a smooth surface. So, here we have sharp edges and here on the other hand we have smooth edges. Now that I am pushing both of them by pistons, cake or clay and wood, what will happen? This wood is rigid and undeformable so long the applied stress is not very high, but this clay material here or the clay material here will easily undergo deformation. The pattern of deformation for case A and B will differ. This line as it is pushed can come over here and the clay material will climb up on the wood surface and it can look like this. Whereas, in case B, here also the clay material climbs up, but the geometry looks different. It can look like this. line AB has come to A dash B dash. Here line AB has come to A dash B dash. The difference in the folded geometry in the clay layer is that here it has produced a round hinge antiform, whereas here it has produced king fold, which is also an antiform. Why is the difference in the geometry of the folds? Why is it smooth and why is it kinked? Geologists link this deformation with the geometry of this surface. Since it is a smooth surface, when the clay material climbed up, it produced round hinge fold, whereas here, since the surface has sharp edges, the king fold is also representing sharp edges. What is a king fold? It is a fold with straight limb and sharp hinges. During this process of translation of the clay material, fault movement takes place. We can put half arrows like this, and we can also put half arrows like that. And here within this portion, we can see that the hanging wall material moves up with respect to the foot wall material, which defines reverse fault. In this case, if I take this portion, the foot wall block goes down with respect to the hanging wall block, and it defines also a reverse fault. These diagrams we will revisit when we do the cross section balancing. Now, we want to learn a few basic things about the faulted terrain. Here we are not going to do the basic definitions. I expect you have studied the book by MP Billings and you are aware of the basic definitions and terms related to faults. What is a thrust fault? This is a kind of reverse fault, we can say, where the hanging wall block moves up with respect to the foot wall block, but the fault plane dips less than 45 degrees. Say on the inclined plane AB, there has been a reverse fault like movement, and the AB plane dips at 31 degree. Since it is less than 45 degree, we can call AB plane as a thrust. We will come across the term cross sections in the cross section balancing. What is this cross section? You have already probably studied it based on the field based structural data or the well data, or from the geological map in the structural geology practical exercises, or if you are in industry, you have used seismic lines to define the cross sections. Coming back to the thrust faults and the thrust belts, there are certain rules that we need to revise, certain terms also. Thrust faults can show staircase trajectory consisting of ramps and flats. Consider a fault plane geometry like this, where this is horizontal, this portion is inclined, and again this is horizontal, and suppose there has been tectonic movement in this manner, then this inclined portion is known as ramp, and these horizontal or sub horizontal portions of the fault can be called as a flat. So, here we can say it as a FR F geometry, or we can call it ramp and flat geometry. There can be staircase like several ramps and flats. So, we can call this as, starting from here, FR 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 geometry, or simply as ramp and flat geometry. Flat lies on a specific stratigraphic horizon and usually for a long distance. Consider situation A where the future fault plane has been shown by dashed lines. This dashed line represents the faulting that is going to happen or the future thrust fault, where the thrust fault goes for a considerable distance along a specific stratigraphic horizon such as here, here and here. We call it flat. Ramps cut layers over a shorter distance and they usually dip at less than or equal to 30. Note this number is less than 45 and that is why the word thrust can be used here. Where is ramp? Here ramp is there, here is ramp for a shorter distance than flat and they are cutting the stratigraphic horizons. Thrusts climb up section and towards the tectonic transport direction. Let us understand it. Consider this case. The hanging wall block has climbed up section. This way movement is the up section and it is towards the tectonic transport direction. In this diagram, this is the tectonic transport direction. If I draw this diagram differently, then this is the thrust fault and in this case this is the tectonic transport direction. Next statement, few thrust belt rules. Newer thrusts keep forming towards the foreland direction. However, out of sequence thrusts are also possible. Let us understand it. Say this is the ramp and flat geometry of the thrust fault and this is the tectonic transport direction, then this geographic direction can be called as the foreland direction. The opposite direction is known as the hinterland direction. So, in this particular drawing you note the ramp and flat geometry and the foreland direction is marked. Towards the foreland direction, the hanging wall block is climbing up and the material transport is taking place. If I flip the diagram in this way, then this is the fault movement and this is the foreland direction and the opposite direction is the hinterland direction. These terms foreland and hinterland are used in thrust belt studies and you will also come across in the diagrams related to cross section balancing. Towards foreland, new thrust faults can develop and that is what it says. That means, if this is the first thrust fault produced, the next thrust fault can be produced in this geographic direction. It will not be developed over here. So, if you have a sequence of thrust, if you find several thrust faults and several faulted blocks, one climbing over the other one, such as this, you can make out as per this thrust belt rule what is the sequence of these faults being produced. An exception of this kind of thrust faults movement direction, which is known as in sequence thrusting, is known as out of sequence thrusting, where this rule is violated. Out of sequence thrusts or OSTs are common in collisional orogens. Do not think that OST is unusual. The net slip of thrust cannot increase upward, that means vertically upward the net slip of faults are to reduce. it actually decreases if there is a fold or imprecate faults at the top to accommodate the strain. This is the ground surface and here is a fault. Now, this fault slip can terminate at some point, but because of the push of the hanging wall block and that there is a sinking tendency of the footwall block relative movement, there is a good possibility that the ground surface will get folded like this, because this portion is pushed. It produces asymmetric folds with a divergence same as that of the reverse fault. This is a reverse fault. This reverse fault has a divergence towards the left hand side direction, and this asymmetric fold geometry also has divergence towards the left hand side. Sometimes these folds are known as drape folds. Drape folds, drape means cover, as if this fold is covering the blind fault. Blind thrusts are thrusts which terminate before reaching the ground surface, but if they have reached the ground surface, they are known as the emergent thrusts. The blind thrusts can terminate as asymmetric folds on the surface. These asymmetric folds can be a surface manifestation of the blind thrusts. Thrust sheets are typically characterized by kick folds. Consider the ramp to flat transition is sharp, such as this, then the fold produced here is expected to be kink fold. What are kink folds? These are folds with straight limbs and sharp hinges. What is the definition of a panel? A part of the hanging wall in which the bedding attitude is relatively constant over a large area. Let us consider this thrust belt. Here one panel has been defined within this, where the bedding attitude is relatively constant and here it is horizontal. In this diagram, we can call this as a panel, this as another panel, this as another panel, and here is the fourth panel P4. What is a hinge or hinge zone? It is a narrow zone between two adjacent panels. So, in my diagram, this is the hinge, it is a narrow zone between two adjacent panels. Let us understand the term cutoff point and the term cutoff line. Consider the unfaulted layered rock. Point A and A dash basically represent the same point and it is located over here, but as faulting happens, point A dash has come over here. Point A dash on the future hanging wall and point A in the future foot wall block are shown, and after faulting A dash has come over here and point A is lying there. These points A and A dash are known as the cutoff points. They were together before faulting, and in 3 dimension cutoff points actually define the cutoff line. In this diagram, the cutoff line passing through A is perpendicular to the diagram, and so also for A dash. The cutoff line passing through A dash is perpendicular to this sketch. Let us understand the term hanging wall ramp and the foot wall ramp. Ramp has already been defined, but we have to be careful in using the term hanging wall ramp and the term foot wall ramp. Look at the layers and the fault in this diagram carefully. Here this block is the hanging wall block and this block is the foot wall block. We are going to define hanging wall ramp first. On the hanging wall, layers that are at angle to the fault are called hanging wall ramp. For example, here the layers are at an angle to the fault plane. Therefore, this is hanging wall ramp A. Here we can see that the layers are at an angle with the fault plane. So, this is another hanging wall ramp B. Similarly, here this is the fault plane that goes, and here in this place particularly and in this place particularly an angular relationship is found between layer and the fault. So, this is hanging wall ramp C. Similarly, one can define the foot wall ramp. Now, we are going to consider only the foot wall. Here the layer, this layer is making an angular relationship with the fault, that this is the layer and that is the fault. Therefore, we can call this foot wall ramp B. Similar thing is found here. This is the layer in the foot wall and this is the fault plane, they are at an angle. So, this portion, only this portion can be called as a foot wall ramp C. Similarly, here this is the layer and this is the fault plane and I find an angular relation, therefore, this is foot wall ramp A. In this way, the hanging wall ramp and the foot wall ramp are explained. Now, we want to know the term hanging wall flat and foot wall flat. It is the layer of rock within the hanging wall which is parallel to the fault, such as here the hanging wall layer rocks are parallel to the fault. So, this is a hanging wall flat. Same thing happens here. So, this is again a case of a hanging wall flat. We can call them HWF1 and HWF2. Here also that is the case and there also is the case. So, the hanging wall flat 3, hanging wall flat 4, hanging wall flat 5 have been found. The hanging wall flat 6, hanging wall flat 7, hanging wall flat 8. Do you observe there is a subtle difference in the term between just the term flat and the hanging wall flat? This portion of the fault is called ramp, but then the layers, since they are parallel and they are on the hanging wall, it is known as hanging wall flat. Do you see the difference? On the fault ramp, hanging wall flat is lying, and in this place what has happened, the fault plane is flat and there the hanging wall flat is defined. So, we can write on ramp, that means a ramp geometry fault plane, we can have hanging wall flat. Similarly, we can explore the term foot wall flat. Since the term foot wall is there, we are going to look at this layer and ignore the top layer. In this portion, the fault plane is parallel to the layer. So, these layers, since they are in the foot wall, we can call it as foot wall flat. In this way, hanging wall ramp and foot wall ramp are defined, hanging wall flat and foot wall flat are also defined for a thrust belt.